Okay, so we just derived all the derivatives of the 6 trig functions. So now let's look at finding the derivative of some more complicated equations of functions that require us to know the derivatives of the 6 trig functions. Okay, so to find the derivative of g of x, okay, we have a difference of 2 functions. We can just find the derivative of each piece. So we have 3 times secant of x. You know that the derivative of secant of x is tangent of x times secant of x. So that's going to be 3 times tangent of x times secant of x. And then the derivative of cotangent, you know, is negative cosecant squared of x. So I can actually make that plus 10 times cosecant squared. Okay, and then we'll talk about eventually how and maybe some examples here, how we can maybe make our derivative look a little simpler by using trig identities. This one we're just going to leave. Okay, so our next trig function, we have this first piece, which is 3 times x to the negative 4th. That we'll just be able to use power rule to find the derivative of. And then we have minus x squared times tangent of x. So we're going to actually need to use product rule to find the derivative of x squared times tangent. So h prime will be negative 12 times x to the negative 5th. And then we're subtracting, and now we'll use product rule. So first factor times the derivative of the second factor is secant squared, plus the second factor times the derivative of the first. Okay, and then let's just clean that up. Let's get rid of the negative exponent. And if we distribute that negative in, so we can get rid of the brackets, it's minus x squared times secant squared. And then I'm going to bring the 2x in front so it doesn't look like it's part of the argument of tangent. Okay, and we'll leave there. All right, so to find the derivative of this next function, y prime, we're going to need to use, sometimes you can use an identity to rewrite the function that you're finding the derivative of in a simpler way, and it makes it easier to find the derivative. We're just going to leave as is for this one, but we're going to need to use product rule to find the derivative of sine times cosine. So first factor times the derivative of the second, which will be negative sine, okay, plus the second factor times the derivative of the first, which is cosine, and then plus 4 times the derivative of cosecant, and the derivative of cosecant, remember, is negative cotangent times cosecant. So I'm going to change this to be minus 4 times cotangent times cosecant of x. And then I'm just going to clean this up a little bit, distribute the 5 in, so that it'll be minus 5 times sine squared x plus 5 times cosine squared x minus 4 times cotangent of x times cosecant of x. Okay, we'll leave as is. We're not using the identity here, the Pythagorean identity that we talked about before, so we will leave like that. Okay, and to find the derivative of this next function, we're going to use the quotient rule. So the denominator times the derivative of the numerator. So the derivative of the numerator would just be cosine, minus the numerator times the derivative of the denominator, which is actually going to be 2 times sine of x. And then all over the denominator squared. Okay, now let's see how we can simplify this. Let's distribute the cosine here, so that'll be 3 times cosine of x minus 2 times cosine squared, and then minus 2 times sine squared. And then if we were to factor -2 out here, we'll still have 3 times cosine of x, but let's factor -2 out. So then we would have cosine squared plus sine squared. Which is that handy dandy Pythagorean identity. So just equal to 1, right? This just equals to 1. So our numerator will be 3 times cosine of x minus 2. And unfortunately, that won't cancel with the denominator at all, but that's okay. I'm running out of space, so I'm just going to say equals to 3 times cosine of x minus 2 all over 3 minus 2 times cosine of x squared. We'll just leave that there. That looks nicer than our first step. All right, so this example is a little bit different. So all of the other equations that we found the derivative for, the argument of the trig functions was just x. But notice that the argument of this trig function is 4x. Okay, so we need to think a bit about this as a function inside a function. So we're thinking chain rule. So 4x is going to be the inside function, and then cosine is going to be the outside function. And the 2 is just a constant, it's there. So the 2 is hanging out. Derivative of the outside function, so the derivative of cosine is negative sine. We leave the inside alone, times the derivative of the inside is 4. So this equals to negative 8 times sine of 4x. So thinking chain rule. All right, so this next equation, y equals 2x cubed times tangent of 6x. Okay, so we have the 2x cubed and then times tangent of 6x. So we have a product, meaning we need to use product rule. So first factor times the derivative of the second factor. Since something's happening to the argument there, tangent, we're going to think of as being the outside function. 6x is the inside. So the derivative of the outside is going to be secant squared. We leave the inside alone. Times the derivative of the inside is just 6. Plus the second factor times the derivative of the first factor. So just cleaning that up a little bit, I'm going to rewrite this as 12 times x cubed times secant squared of 6x plus 6x squared times tangent of 6x. And we'll leave that there. Okay, so 2 times sine cubed. So remember that with this exponent here, that's the same thing as sine of x being cubed. So it's sine of x times sine of x times sine of x. So I'm going to rewrite it like that to help remind me of that. And now I need to use chain rule. So in this case, we're going to think of sine as being the inside and the cube as being the outside, and then the 2's there, or it's just the constant. So derivative of the outside, we'll multiply 2 by 3, so that'll give us 6, and then subtract 1 from the exponent, that's 2. Leave the inside alone, and then times the derivative of the inside will just be cosine. So we'll just leave that there. And then we have this last one. So now this is like a function inside a function inside a function. Okay, so let's rewrite this as sine of 7x squared. So let's first think about the square as being our outside function and sine of 7x as being our inside function. So g prime will be equal to the derivative of the outside, leave the inside alone, and then times the derivative of the inside. Well, now here's where we have to apply chain rule again, because we can now think about, for finding the derivative of sine of 7x, as sine as being the outside function and the 7x as being the inside. So the derivative of sine is going to be cosine. We leave the inside alone and then times the derivative of the inside. So that was a lot of chain rule. Okay, let's clean that up. That's going to be 14 times sine of 7x times cosine of 7x. And we're done.